Hi, welcome back to this PI-KEM video series covering how to create the perfect coin cell. I'm Georgia, and in this video we're going to be moving on to covering electrode disc cutting, the stage where larger coated electrode sheets are turned into precisely sized discs ready for cell assembly. In the previous stage, we calendared our coated and dried foil sheet to create a dense, uniform electrode. The coated and calendared electrode sheets must now be cut into precise discs in order to fit within the coin cell casing. The cutting process must produce precisely sized discs with clean edges without damaging the coating or deforming the metal foil. In this video, we'll cover how good cutting technique helps to ensure that the electrodes assemble correctly and perform consistently once inside the cell. The quality of the cutting tool is extremely important. A sharp, well-made die produces clean and consistent cuts. A dull or poorly maintained cutter can create rough edges and burrs, stretching the foil or damaging the electrode coating. Quality cutting dies maintain their sharpness over many cutting cycles and can be supplied in different diameters to suit a range of coin cell and pouch cell formats. Many disc cutters are also designed for glove box operation, allowing electrode preparation to continue in controlled environments. Position the coated foil over the die of the disc cutter. Careful spacing between cuts helps to maximise the number of electrodes you can produce from each coated foil sheet, reducing material waste and improving consistency between samples. Take extra care when positioning the foil near the coating edges. An electrode disc with an incomplete coating will affect the cell performance. Once the foil is properly positioned, apply firm, even pressure to the handle of the disc cutter. The aim is to create a clean cut in a single motion, without distorting the foil or damaging the coating. Handle the cut electrodes carefully using clean tweezers, touching only the edges wherever possible. Avoid contact with the coated surface, as oils, dirt or moisture contamination can affect electrochemical performance. Inspect each electrode after cutting. A well-cut electrode disc should be perfectly circular, with smooth, clean edges and no visible burrs, tears or rough spots. The coating should remain fully intact, with no cracking, flaking or lifting from the current collector. Defects at the edges of the electrode disc can create problems later during assembly or cell cycling. Common cutting defects can usually be traced back to tool condition or handling technique. Recognizing these defects helps to improve both electrode quality and process consistency. In the next stage, these precisely cut electrode discs will be assembled along with other components into a cell casing before being crimped into a final complete coin cell. At PI-KEM, we can supply a broad range of precision electrode cutting tools for battery research and development. This includes manual disc cutters for coin cells, larger cutters for pouch cell applications, and interchangeable die sets for different electrode diameters and cell formats. We also offer glove box compatible systems and automated cutting solutions for higher throughput workflows. Combined with our coating, calendaring, and electrode processing equipment, these tools help to create a complete and repeatable coin cell manufacturing workflow. Explore our full range on our website or get in touch with our expert team to discuss how we can support your battery research journey.